Welcome back. For today's deep dive, we're looking at something you've probably seen and maybe even complained about.
You mean those giant satellite farms on apartment buildings?
Exactly. Just a mess of dishes on a roof.
Yeah.
Our mission today is to figure out how technology is consolidating all of that clutter into a single, clean fiber optic solution.
And the key piece of hardware we're focusing on is the Thor Broadcast F-LB41-CWTX. It's a device that's really built to, well, take that entire array of antennas and shrink it down to just one dish.
While still serving dozens of homes.
Right, and it's designed to work with the big players like DirecTV.
Okay, so let's get into the magic of it. Satellite systems use 4 distinct feeds, or polarities, right?
Mm-hmm.
4 separate L-band feeds.
And we're talking a huge frequency range here, something like 950 to 2400 megahertz. How on earth do you cram all of that onto one single tiny strand of fiber without it all just turning into noise?
Right, and that's the core technical challenge. The answer is a technology called CWDM.
It stands for Coarse Wavelength Division Multiplexing. If you've ever had to manage one of those apartment complexes, you know what a nightmare all that coaxial cable is.
Oh, yeah.
So what this device does is it takes each of those 4 incoming electrical feeds and converts them into an independent optical RF channel.
So you're essentially turning each signal into its own unique color of light.
That's a perfect way to think about it. Each color, or wavelength, is its own private lane on the highway. The system uses 4 very specific wavelengths, spaced about 20 nanometers apart.
And then it just combines them.
It combines them internally onto that single fiber output. They all travel together, but because they're different wavelengths of light, they just don't interfere with one another. That separation is key.
Okay, so the physics make sense. But what about the practical side? The scaling. I saw a number in the sources. 32 endpoints, like 32 separate homes.
32, yeah. And that kind of capacity is why property developers are paying attention. Once you have that combined optical signal, you can use something called a PLC coupler to split it.
A PLC coupler.
Think of it like a power strip, but for light. It lets you do what the industry calls fan-type distribution.
So you're fanning that one signal out to a whole neighborhood, basically.
Essentially, yes.
Hold on, though. 32 endpoints is impressive. But every time you convert a signal, say from electrical to optical and back, aren't you introducing another point of failure? Doesn't splitting the signal add noise?
That's a great question, and with traditional copper coax, you'd be absolutely right. Every split adds significant noise, you lose power, the signal gets worse over distance.
Right.
But that's the real game changer with CWDM fiber. Because you're dealing with light, each of those 4 channels stays perfectly clean and separate until the final conversion, right at the endpoint. The distance and the number of splits, they matter much, much less.
That's a huge structural advantage. So zooming out a little, the sources mentioned this device has a really wide frequency response, up to 2700 megahertz.
It does, and that's important for ensuring it's compatible with all the existing satellite standards. But what's really fascinating here is that this isn't some standalone one-off product.
It's part of a bigger trend.
Exactly. We're talking about satellite TV over fiber, but the sources also mention things like GPS over fiber, even telephone lines over fiber. It's all part of this platform shift, moving signals that were traditionally copper-based over to a unified fiber infrastructure.
So for, developer and infrastructure manager listening, what's the bottom line here?
The real insight is that when you combine L-band frequency handling with CWDM optics, you get this incredible jump in efficiency. It's about architectural simplicity and much, much better signal quality. You're cutting costs, maintenance, and the ugly physical footprint of the whole system.
So here's something for you to think about. If a system can reliably put 4 huge satellite signals onto a single strand of fiber, what other clunky copper-based systems are next? What about municipal monitoring, or maybe even massive data center links? It seems like a lot could be streamlined this way. Thanks for diving deep with us.